Exercise 6 illustrates the use of data tables. So we use a data table when we want to compute something under different scenarios. So in this example, we have Pebbles and Bam just had a baby and are saving for the child's college education. They're going to deposit $100 at the end of each month, and for 18 years. Okay. So we have our timeline in years because we're going to use, no, actually we have our timeline in months because the interest rate is convertible monthly. Okay. So 18 years, 18 times 12 is 216. So my timeline goes all the way down to 216, as you can see. Down here, okay. And then in column B, I put in my deposits. I'm going to make a deposit of $100 at the end of each month. Okay. And then in column C, I'll compute the balance in the account as the usual way. I take the previous balance, multiply by 1 plus the nominal rate divided by n, and then add any deposits made at that point in time. So we copy that formula down, and we see that we end up with, how much would we end up with? We end up with $31,559.24. So, so that's the answer to the first question in part A. How much will they have saved up by the child's 18th birthday? The second part is how much interest will they have earned? Well, so whatever money is in the account apart from the deposits is interest. So the deposits add up to $21,600, 100 times 216. And so the interest would just be the 31,559.24 minus the 21,600. Okay, so they've earned $10,000 in interest approximately. Now, what we want to know is, so we've done this assuming 4% convertible monthly. Okay, so I used in my formula here, I used the nominal rate of 4% convertible monthly, and that's the cell nominal rate that I used in my formula. Right? But I want to replace 4% with, say, 3% or 3.5% or 8%. But I don't want to, I want a faster way to make that computation several times. So what I do is a data table. So I listed the interest rates that I'm interested in a column here. And then in this cell, I put the total that I just got for the answer to part A, right, which is in cell C218. Okay? And that was computed using this cell for the interest rate. So the data table is going to allow me to replace whatever's in that cell with one of these numbers and compute the corresponding balance. So what I do is I select these two columns, and including the first row, which has the computation that I just did for 4%. And then I go to data, what if analysis, data table, and my the inputs are in a column, so I leave the row blank, and in the column I say these amounts that are in this column are going to be replacing the amount in cell H3. So I can put H3 there, and I say okay, and then it computes the ending balance, assuming each of those different interest rates. And you can see that for 4%, it gives me the value that I got before, because before I did it, assuming I was 4%. Now in part C, we have two things that we want to change. We still want to look at those different interest rates, but we also want to see what happens if we increase the deposit amounts by some fixed amount each year. Okay, so maybe they're getting raises and so their income is going up each year, and they feel they can increase their deposits each year by some fixed amount. So what would they have in their account at the end of 18 years if each year they increased by $10 or $20 or $100? All right, so for that, I'm going to, actually I'm going to go over here. Okay. So I've got my interest rates here, and I'm going to, so I've got a cell here for my nominal rate of 4%, and it's convertible monthly, and then here I'll just put a value of $10. So suppose I'm going to increase the monthly deposit by $10 every year. Okay. So I've called that X. So I go over here, and I've still got my timeline in months, so it goes down to 216. My deposits are $100 for the first 12 months, and then it's the previous deposit, no, the deposit 12 months ago plus X, so that makes it 110. And if you go, if you use that formula, B3 plus X for B13, and copy that down, then that will, it will always go back a year, and so for the next year it'll be 110, and then for the year after that it'll be 120, etc. Okay, so that's what we want. And then column C is computed the same as before, and so under 4%, and assuming we're increasing the deposit by $10 each year, we end up with $55,021.32. Okay, that's cell 218. Okay, so now we want to do a two-way table so we can see what happens if we change the interest rate to something else. So here are our different interest rates. And if we change the amounts by which we increase the monthly amount. Okay, so we did $10 just now, but we want to see what happens if we increase it by $20 or $30 or $100. So those go on a column. And then in the corner of the table, we put the computation that we just did for a particular interest rate and a particular value of X. Okay? And that was, remember, in cell C218. So this amount is the amount under 4% and X equals $10. So what you do, and actually I should delete this so you can see what happens. So I select the whole table here, and again I do data table. Now I have both a row and a column input cell. So the row would be the row amounts here, which are going to replace X, right? So it should be this amount, okay? In cell I5, sorry. And then the column input cell is where I have the interest rate, which was 4% for my example. So that's in cell I3. And then I say OK, and it fills in the table. and you can see that amount, which is the for 4% and $10, is equal to the amount that I got before using 4% and $10 for my values.